Okay, let's have a look at biotech. How do genetic techniques affect the Earth's biodiversity? So in this section here, we're going to link it all back to genetic diversity. So biotechnology, we're going to start by looking at what are the social implications and ethical uses of biotech. We're going to look at what are the future directions of biotech, what are the potential benefits of society of actually using genetic technologies, and what are the possible changes that occur to the Earth's biodiversity as a use of genetic techniques. So this is our inquiry question: how do genes affect Earth's biodiversity? So let's begin by looking at what is biotechnology. So pretty much everything around us is biotechnology, right? Medicine, industry, food, energy, environmental sciences, computation, all of these things where we actually mix science and technology, that is biotech. And any technological application that uses biological systems and living organisms or derivatives thereof to make or modify products or processes for a specific use. So washing machine liquid, yogurt, because it's been fermented, butter or margarine, canola oil, all of these different elements around us, they are all produced through modification and the application of scientific procedures. So basically, biotech is technology based on biology. So let's talk about medical biotech first of all. We are all very familiar with them. It includes pharmaceuticals like vaccines and antibiotics, stem cell therapies. So stem cell therapies, for example, like skin grafts, the treatment of cancers and autoimmune diseases. That's also another example of medical biotech. So autoimmune diseases like treatment of type 1 diabetes using insulin created using penicillin. That's there. There we go. Bio-inspired materials like spray on skin, and finally diagnostics like biosensors, and we know how prominent biosensors are now in sports, and so on. Industrial biotech, it includes enzyme biotechnology, so improvement in enzyme biotech to actually improve the efficiency of industrial processes, includes biodegradable plastics and like production of biopolymers that are derived from plants and bacteria, and also energy sources including biofuels and photosynthesis. So the modification of these processes to try and produce different alternatives. Environmental biotech, so bioremediation is the use of microorganisms to clean up pollution, like algae, for example. And agricultural biotech is the biggest example is genetically modified organisms, so GMO crops that are that are being used to lead to better yield, and also to be more suited to the changing environment. So what are the positives, right? I actually want you to think about this. What are the positives of using biotechs? Well, first of all, it meets the growing needs of society, right? Like, we are obviously growing population. Population is growing, our resources are limited, and so by using these biotechnological products, we can meet the growing needs of a society. We can try and reduce that pressure on the environment, and we can improve quality of life through it. And that includes, for example, meeting the United Nations sustainable goals, so like ending poverty and hunger, improving health and well-being of individuals, access to clean water and sanitation, clean energy, sustainable cities, right? And so we are harnessing the power of biological tools to invent new creative solutions. In terms of genetic diversity as well, there is a positive because it leads to the creation of new arrangements of genes and new allele combinations. And it also allows for organisms to actually adapt to their environment. And ultimately, as a result of that, it can lead to the process of evolution being accelerated. And we now, and another big sort of part of this is open source information, which is a bit of a gray area here, but we can count it as a positive because it does lead to the creation of public databases, which allows for a growing amount of biological knowledge to actually be shared amongst people. Though there are concerns, and many at that. Firstly, ownership. Should we allow people or big corporations to actually own biological information? And there can be economic benefits, right? And that can lead to like the production of monopolies that possess biological processes, and the intellectual property constraints as well, so they can become prohibitive to process. So there is that line, between natural and synthetic that is being blurred. Commercial implementation is another one. Again, biotech monopolies, companies that have vast resources, that have vast finances to actually dominate the market, drive up the prices of the products, and that can then be detrimental to the people who need it the most. And there's that program dependency on these big firms. Consumer rights and choices is another big one, and we also want to consider regulation. So governments, can they strike a balance between safety and innovation? Biohacking is another one, and also eugenics. So, future directions of biotech. So there is continual improvement and refinement of current technologies, and creation of novel approaches to emerging issues. And there's that growing, I guess, what's the word here? There is that growing use of backyard biotech, of people actually experimenting, and so we know that synthetic biology is an interdisciplinary approach where we can have an engineering approach to creating biological tools. We can combine molecular biology, genetics, biophysics, computer engineering, and we can break down our understanding of biology into parts and then rework that to create new innovative solutions. And this is driven by like student-led competitions. The innovation is pretty significant. But how does it affect biodiversity? So positives are that crops may be insect resistant, and so that means that we don't need to use harsh chemicals which impact the environment. Crops may also have increased stress resistance and productivity, and that can lead to us maximizing the use of restricted land. Also growing vegetation where there are harsh environmental pressures. So we know that we can try and grow vegetables in like inside buildings, or like eco hubs and stuff. There is research into that's happening, and in fact it has already been implemented, and also there is a deliberate introduction of variation through this. However, there is the ability for GM crops to outcompete natural crops. There is also the establishment of monocultures, of just like having one type of species of a certain thing, because it's like it has like good environmental yield and it's cheap and inexpensive. So a good example of that is like Cavendish bananas, and so that can lead to the loss of genetic diversity. There's also horizontal gene transfer into native ecosystems, and competitive advantage can also lead to loss of naturally occurring alleles and variation. So when we evaluate this, and you should be able to you want to evaluate this, in your own understanding, and I would recommend like having more examples to back up these points. Remember, I'm just, outlining the content to you here. I definitely recommend going ahead and doing some more research, adding to these notes. So when we evaluate this, we can obviously say that agricultural practices, they are driven primarily by short-term economic profit, and they have posed a risk to biodiversity. However, biotechnology gives us the tools to enact this at a more rapid pace, and also at a more fundamental level, or a more genetic level. It does have a huge potential to help the agricultural industry, but it has to be used wisely, and with the consultation of necessary stakeholders. And that is evaluating the effect of biodiversity of using biotech in agriculture. Again, I'll skip these, but definitely recommend you go through it.